Hello, my name is Jillian and I am a bioinformatics infrastructure consultant. And today we will be talking about how you can run really large, complex, high content screening pipelines. So the data set that we will be using is this data set that is publicly available. This human MCF7 cells, they are cancer cells that were treated with different chemicals. And as our kind of framework of choice for managing our analyses, we are going to be using Apache Airflow. I really like Apache Airflow. I'm really surprised by how much I like Apache Airflow because, and from now on I'm just going to call it Airflow. Because, you know, all these tools, they're really cool and they're really cool for like a couple weeks and then something else comes along. But I have to say, Airflow, I've been using it for just about 2 years now. And I still really like it. And I think this example that they have, this is like an example analysis that they have when you spin up Airflow. It spins up with some examples. This one right here demonstrates really well. So what you can have is you can have your analysis. It's all drawn out. And you can have the first thing that happens, the second thing that happens. And then say you have something here and you need to make some kind of like programmatic decision about what happens next. Maybe if your analysis, you're doing some QC, and if it hits a certain threshold, you go to the next part. And if it doesn't hit some certain threshold, you do some more examination on the QC side. You know, things like this. So these being able to make like programmatic decisions about your workflows, these are all really nice bonuses. And then additionally, what you can do is you can use Airflow to integrate with any other number of systems because it is code. It is this idea of having your analysis as code, which is something that's really nice. There's also another idea of having like infrastructure as code, which is sort of a similar process. But today we're talking about analysis. So anyway, so what you can do is you can use Airflow you can use it to manage your processes from almost anything. It can integrate with a lot of different systems because it is code. It has a REST API, it has a CLI, it is also, you know, it's like we keep saying, it's just code. So if say you have a LIMS system, you could say, okay, for the LIMS system, when a certain analysis is finished or when a certain microscope it finishes imaging the data, then I want to go and I want to fire off this analysis to Airflow. And Airflow keeps track of all of your dependencies. So you code up your analysis, you code up the dependencies. It's very flexible. So you could actually have like different analysis types for different experiment types. That tends to be how I like to organize code. I do less of the elegant code stuff and more like functional organization. So if I have a particular analysis type, I'll have that together, so on and so forth. But that's getting a bit philosophical for right now, I think. So if you have, if you have large data sets and you want to batch them, I talk about that in another video that I'll link to below. You want some nice way to handle that, and usually what you use is you use a job queuing system. And Airflow has a job queuing system built in, and it also keeps track of this stuff that we call state, which is it's one of these things, it's much harder to code than you would think that it would. So for instance, if you ran this analysis, this is like, it's a fake analysis, or it's a fake analysis, we'll go with that. So you can see you have all these different potential states. You have that the step was successful, you have that it's running, that it's failed, that it was skipped for some reason. So say you're doing these programmatic decisions, and then, if something fails, so say this step here failed, then this one here would be orange. Up for reschedule, up for retry, queued, no status. All of these right now are no status. And because you have this nice interface, you can also see right now exactly where all the steps are at. I would think these ones would be no status. Oh well, that's okay. And one kind of nice thing is that the code is actually included. It's included like right in the interface. So you can see it's right here. And then because Airflow is very, very flexible, there are different ways that you can trigger these analyses. So you can trigger the analyses manually or using something that's outside of the system. So for instance, this setup that I discussed earlier where you have a LIMS system and the LIMS says, okay, imaging is done, and then you go and you trigger an analysis. You could do something on like a cron job kind of schedule where you look for something daily. That, for instance, that's how this one is organized. Daily, monthly, any kind of cron schedule that you could have. You can do things like you can wait for files to appear on a file system. All these different things. It's very, very flexible. I really like the way that it's organized. And the other thing that I really like about Airflow, particularly for me, is that it's very agnostic to the compute backend that you're using. So if you have a laptop and you just, and you feel like, hey, I could get this done on my laptop, but I can still do some batching. I could still use the need for the job queuing system for all this kind of thing. You can use Airflow on your laptop. You can use Airflow on your laptop. You can use it if you have a couple of virtual machines or servers around. You can wire those together into a Docker Swarm cluster. You can use it on Kubernetes. You can distribute it all. You can put it on just an EC2 instance if you're on Amazon. So then that's the Airflow. And then when you're actually executing your tasks, you may need to execute them other places. So for instance, maybe, back to the LIMS example, you have the LIMS, you have some sequencing that's done or a microscope that's done, and then maybe you have an in-house HPC system. Well, you could tell Airflow to go trigger a task on the HPC by using the SSH executor. So that's an idea. Or if you're using AWS, maybe you're using the Elastic Container Service. There's an operator in Airflow for that. You could say, okay, so for this particular task, I want for this to be on the AWS Elastic Container Service or on AWS Batch. Or if you're using Kubernetes, which is kind of my favorite lately, then you could actually say, all right, just bring up a new pod. You could use a Docker executor. You can execute Bash. I was trying to say like Bash and Python at the same time. Bash, Python. You can execute any number of things. So that's kind of why I chose Apache Airflow for this particular instance. But probably what you're really interested in is hearing less about Airflow and how you can use it for CellProfiler, right? So you have all of these things. This is all going to be linked to below. What you want to do is you want to grab this DockerCompose file. This comes from Bitnami. If you're ever looking for Docker containers or for like setup systems, so for instance, this one is DockerCompose, go check out, see if Bitnami has a configuration for you to use. Everything that I've used from them has been really high quality. Love them. Like, I talk a lot about how much I love Bitnami. But you can see we have our services all set up here. One of the things that Airflow does is because it keeps track of, because it keeps track of like all this information about the state and the kind of analysis, and you also get like logging and timestamps and when it was executed, all this kind of stuff. It needs a database backend. So you have that in here. You have Redis. That's for like real-time communication. I don't want to get too much into that. That's getting a little bit too techy. Just know that it's there. You have the Airflow scheduler. If you've ever been on an HPC system or used any kind of job scheduler, Celery, HPC, even Spark has like a bit of a job schedule in there, I think. You will be familiar with a scheduler. It's what jobs run in what order. And then you have your worker. That is where things are actually executed. And that's that. And then because this is Docker, what I'm doing is I have the files, they're being written on my local file system so that I can use my IDE with my nice, with all of my nice syntax checking, and then I just bind these volumes to the Airflow containers. So we have that. Oh, see, and there's a nice cell image. Anyways, so what we're gonna do here is we're actually gonna go and we're gonna take a look at this in the interface. Oh, actually, no. We're going to talk about how you would bring this up. So what you would do is you would go to your project root, and then you would do DockerCompose up. If you haven't run this before, it's going to take a little while because it's going to have to download all the images and do the initializing. That's why I don't do that here, but you can see, it's pretty simple. Once you have everything in your Docker container, and you also have these DockerCompose configurations, you can make yourself some very nice development environments. So we have this, and then kind of what's typical in an Airflow instance is that you have this directory called DAGs. DAGs are directed acyclic graphs. These are the steps. This is like the logic of your analysis. So this says do step 1 and step 2 and step 3. And then there's also kind of a description of the operators and the sensors that are used to execute your tasks. So for instance, what I was talking about earlier, say you want to execute some Python command, you would use the Python operator. If you wanted to execute some bash commands, you would use the bash. I think kind of the easiest way to sort of demonstrate this, don't mind my IDE, it was freaking out a little bit earlier. And so then I don't have it set up so that it's using the correct interpreter. But don't worry about that because it's fine. Okay, so what we have here is we have our DAG. Again, that's like the bucket that we're throwing our analysis into. I am saying this is the CellProfiler Illumination. I'm going to talk more about the specifics of the analysis in a minute, but I wanted to take a minute to discuss sort of the Airflow, kind of a few of the concepts that you need to know. So you need to know that you have a DAG, that's your bucket. And then your DAG is comprised of tasks, and each one of these tasks is sort of described by using an operator. And you can think of the operator as being the kind of like computational backend that you're going to use. Maybe you're going to execute Python, SSH, Docker. Again, there are any number of operators. Even like when I'm not using Airflow, if I need to know how to execute on something and I can't quite figure out how to do it, like a lot of times I'll just go and look at the Airflow code base. Airflow also, it has this very nice kind of way of doing templating. So if you've ever run a command line program, what you do is you can pass arguments to it, right? And that's very important for, you don't want to have things too hard coded. You want to be able to use them several times. So Airflow does that by having this templating system. You pass in a configuration object as a JSON string. There are a few different ways to do that. I'm going to show you one. I'm going to show you one through the web UI, but there are several different ways to do it, just so that you can kind of keep that in mind. So we have our DAG, and then we have our operator, and our operator is describing a task. And then the task is actually like the instance of the operator. And then for this one, yep. Okay, so we have our Illumination DAG, the CellProfiler Illumination DAG, that is comprised of two tasks. The first one is the Docker operator, and then the second one is to trigger another analysis, which just means that we're gonna, if this one exits successfully, we're gonna go and we're gonna trigger another analysis. So after we have done that, then we also have our analysis DAG. And this one, it looks very similar. You have these default arguments. Don't worry about those ones too much. You have your DAG, your directed acyclic graph. You have a task, which is an instance of the Docker operator. We are once again passing in some arguments. And then we have a second task that's just gather the results. So this one is a Python operator because I want to programmatically gather results. And then I don't have it here, but presumably you would want to do something with these results, right? You get all of your nice measurements of all the nice cells, and then you would want to go and you would want to do something with them. So there we go, we have that. Now that I've talked a little bit about Airflow, I want to go back and I want to talk specifically about this analysis. So this analysis, it has quite a bit of data. I don't use all the data here. I have a demo instance. If you are interested, you can contact me about that, where I have all the data downloaded. It's all in Apache Airflow. You can kind of see how the whole entire pipeline runs. And it's on AWS. But I mean, like, look at this. I'm not going to have all this on my laptop. I keep filling up the storage on my laptop. It's getting to be a problem for me. Okay, so anyway, so what we have here is we have two CellProfiler pipelines. The first one is an Illumination pipeline, and then the second one is this analysis pipeline. And that is why we have the two different DAGs. We have two different DAGs here, right? We have the Illumination DAG and we have the CellProfiler analysis DAG. And where's this one? Okay. So now that we have this, we're going to talk a little bit more about this. So what happens is that kind of the chain of operations is that we are going to somehow trigger this analysis to run. Once again, how you're triggering it is going to be like very specific on you and on your use case. But the point here is that we are triggering it, and we do have some kind of data that we're using to actually run our pipeline. Much like if you have a command line script, you supply it with arguments. We have the same thing here. We're just doing this with a JSON object. All right, so if you wanted to do that, you could take this, and then as you can see, I've already run a few of these, but I'm going to show you how to do this. Oh, let me go back there. Okay, so what you have here is you have all of your DAGs. And because I started this up and I told it to load the example so that I could show you guys that, you also have all these example underscores. We're going to ignore that. make sure that your DAGs are turned on. And then if you're following along, you want to go and you want to grab this example trigger. This will be, you don't have to worry about changing anything for this one because this is within your Docker container. This is how it's mapped. And again, this is why it's nice to use Docker. So then we're going to go on over here and we are going to trigger this DAG. Right, and we are going to supply this configuration. This is optional. You might have a task that doesn't have this. I don't know. Okay, and then you see it brings us back to this main screen. This one is running. And then we have the run ID. This is, depending on how you trigger it, you can actually give it a run ID. So for instance, if you trigger over the REST API, and I think maybe even programmatically, you can do this too. You can give it a proper run ID, which is really nice because chances are you want something more descriptive than this. But anyways, there we are. So then once we're there, let's go look at the log and hope this worked. I have this problem with live coding because I'm always tinkering with things and then things don't work. Okay, so this is CellProfiler output. It hasn't complained at me that it can't find anything. Everything is good. So you can see that this is going here. And I hope you can see how this gets to be extremely powerful as you're going on because, think about it. You have your job queuing, you have keeping track of state, you have keeping track of logs transparently. So, I think all bioinformatics people, we like to write our own systems that do this. And I too wrote one and, keeping track of the states and the logs and where do the logs go and how do you kind of nicely access logs. It's a much bigger deal than you would think. So having a system that does all this for you, it is very, very, very nice. Now, I also could have just refreshed the page from here. One kind of quick thing about this is that it doesn't refresh the page automatically. So if you're a bit used to kind of newer web interfaces, they tend to refresh automatically. This one doesn't. You have to refresh it. And then you can see, okay, so the first step in our analysis, this completed successfully. So that is great. And if we actually wanted to go and see the rendered template, so if you remember what we had here for our DAG was we had this command, and this command had quite a bit of templates in it. And then we passed in some arguments. So if you ever had to debug that process, as you probably will, you could go and you could take a look at the rendered template and you could see exactly what it looks like. So you can see the command, the environment, and the container name. So there we go. That's pretty neat. So you could even programmatically give a container name as well. Anything that's in this rendered template means that it can be passed in through those initial trigger arguments. And then you could go and you could look at the task instance details. And you can see the state. The state is that it's successful. And then you have quite a bit of other information. You have quite a bit more about the state, what time it started, the pool. So the pool gets to be very important for when you're really fine-tuning your parallel execution. You need to know how many parallel processes you're allowing in the pool, and then you can override that within Airflow itself, but just so that you kind of have an idea of what that is for as you go forward. You can see, once again, you can see the command here. It's not filled in for us, but that's fine. We can go on over to the other one. And then you can see the downstream task IDs, and you see you have a lot of information in here. There is a lot of information that you can get from this. So there we go. So we have all that. And then secondly, what we have is we have this trigger analysis, which looks like something bad happened. Did something bad happen? Yes. So I don't know why this keeps happening. So I have a file here that I read in to get the number of lines. So we're just going to get rid of this one for right now. Okay, so what happens is that, I was discussing this whole process of batching. And with CellProfiler, what you can do is that for most of your analyses, you can actually split them up into the different image sets, and then it can one by one analyze the different image sets. And most often what you have is you have a data file that describes the kind of the structure of your experiment. And you can just go and you can read that in, and then you can programmatically decide on the number of batches. And that is exactly what we are doing here. Well, I mean, theoretically, it's what I'm doing. For some reason, this file keeps getting clobbered. But that's okay. I will figure that out and I will update. So what we have here is we have our trigger analysis task. Okay, so here's the trigger analysis task. It is an instance of a Python operator, and then this is the Python callable, is this trigger analysis function. So we have that up here, and then what I'm doing is that I'm programmatically figuring out the number of analyses that I then want to submit to Airflow. So this is also like a really kind of nice reason, or kind of a compelling reason anyways, to have your configuration for your analyses in code. It is so much easier to do things like programmatically figure out the number of tasks that you're going to submit when you're doing things in code. So I don't know, that's the end of my rant about that. But anyways, this is the function that's failing. It's failed on me a few times before, so I know why. For some reason, this data file, it keeps on getting clobbered. Because this one is just a demo anyways, I don't even actually use it. So I'm just saying, I think for this one there are like 200. I could submit 200 individual tasks. I'm not going to submit 200 individual tasks because this is a demo. Again, if you want to see a real demo, please contact me. I have my contact information. It will be listed below. So I'm actually saying that just, for just 3 example data sets to then go and trigger a DAG. So then what we're going to do is we're going to use this, and then we are going to programmatically trigger this DAG over here. And I do just kind of want to say this is probably a bit like not exactly the way that Airflow expects to be used. Airflow expects to be used more in this kind of situation where you have your analysis completely mapped out. That doesn't always work for me so much because I tend to have much more of these kind of like programmatic analyses where I need to do a step and then I sort of programmatically figure out the next step, figure out the next step, figure out the next step. But because it is so flexible and because you can, you can trigger external DAGs, you can trigger different tasks, you can programmatically watch those tasks. Like as long as you have some information about what you're doing, it's just like any other job queue system. You can sit down, you can watch it, you can get the state, you can do everything that you need to do. So anyways, what I am saying is that for each kind of unit in our analysis, what I want to do is I want to trigger an additional, trigger this additional DAG here. And this DAG is the CellProfiler analysis. And you will see for this one, I'm actually giving it a nice a run ID. So this one is not a very nice run ID. It would be nicer if it had like a nice, I don't know how many times I just used the word nice, like this. So, if I was doing this and I was really like sitting down and properly doing this, I would make sure that each DAG is named, is named for like its analysis type. I like to make sure that things have a very kind of human readable functional name, not just a computer name. I care less about the integer types and more about what I'm actually doing with things. So there we go. So then you can trigger this. You can pass in the configuration. So you'll remember earlier we passed this in just by using the web interface. Now we are programmatically triggering this DAG. And then we are just passing it in. We're just passing it in as code. So there you go. And then triggers append trigger. So then what you could do is, say, I don't know, then you could do something like you could watch the triggers and then do, I don't know, and then carry on to the next step. It just depends. It depends on your analysis exactly how you're going to structure this. Yeah, so it depends on your analysis exactly how you're going to structure this. For analyses that are very, they're very, very, very programmatic, what I tend to do is I tend to have a DAG that's like my controller DAG. And with the controller DAG, I fire off sort of like my sub-processes. And then that's kind of the spider. The controller DAG is like the spider that sits in the web and kind of waits for everything to finish and figures out exactly what's going on. Once again, exactly how you structure things, it's going to be very particular to your analysis, and I don't know. I feel like it's a little bit like touchy-feely too. It just depends on what you like. But I guess this is good. So this died. I'm going to go and I'm going to show you how you can retrigger this analysis. Oh, there we go. So, okay. So let me show you that again. So for this trigger analysis, where's my retries? Okay. So for Airflow, you can actually set like a certain number of retries, and you can set this retry delay. So what happened was that it failed, and then I went and I updated the code so that it would work. And I guess I got it in this 5 minutes, because then it updated and it ran and it worked. But if you either didn't have a retry, or if your retry failed anyways and you went through and you updated, what you could do is you could do this. You could clear this. And then see, look, now the state is cleared. Now we are all set to rerun it. I kind of, I'll just mark this as a success. Yep. And then once again, you can see the code from here. You know, so this is quite nice as well, especially if you're working with a lot of people, or other people are working with you and you just want to quickly show them something. You have everything in one place. Or like if you're using something like Swarm or Kubernetes and you're building Docker images and you're saying, hey, did that actually update? You could go and see if it actually updated. So then let's go and take a look at this. So just as sort of like a quick disclaimer, actually I'm going to delete these. Okay. And then once again, you have this whole nice interface where you can go through, you can delete things, you can update things, you can manually rerun things. I'm really surprised by how much I like Airflow. Where was this? You can have this search. So let's say that I go here and I want to search for everything that's been run. Okay, so you can see that I have the CellProfiler Illumination. You can see these ones from yesterday when I was first working on this. And you can see that I have this manual run ID. And that then this CellProfiler Illumination, what it did is it triggered these other CellProfiler analysis tasks. And I have this named based on the batch. If you're unfamiliar with batching, I have another video on it, but the idea is that you want to split all of your analyses into the smallest steps possible. And each one of those steps, you want to see if they can run in parallel, because this will save you on computational time, and it will just generally get your stuff done faster. It's also quite a bit easier to debug, because if this, say for some reason, this one failed, but these ones didn't, you could just try to force rerun this. It might work, but it gives you a much easier starting place to say like, okay, this one didn't work. Why didn't it work? Let me go figure that out. So anyways, there we go. Then we can look on this. We can see our analysis. It is still running. So once again, I can go over this state and I can kind of see which tasks are in different states. And here's the analysis. I want to look at the logs. So there we go. We can see that CellProfiler is running. It is actually running within a Docker container, because that was, if you remember, that was the operator that I used. I used the Docker operator, which means if you're working on any number of servers, you don't have to install software to all of them. You can just use the Docker operator or the Kubernetes operator. And as you can see, here it goes. It's going, it's going, it's going. We can once again look at the rendered template. I don't know. Maybe we can look at the render template. Maybe we can, maybe we can't. Okay, see, now this is just getting worrisome. Can I just go back to the home page? I don't know, it's freaking out. I think probably, I should have been a little bit more careful about how I set these things, because I think probably running 3 of these analyses in parallel is a bit much for my computer. Especially since I like my fancy IDE, and you That's using quite a lot of gigs right there. Okay, so we'll go back and we'll talk about this some more. So, okay, so let's say we have this output, and I have this output. I have it over here. Okay, see, so I have, okay, you can ignore these. But see, so I have the output, and the output is based on the first and the last, and I have, let's look at this one. See, and then there we go, we have this nice image. And then most often what I see is that afterwards, once the analysis is run, what you actually get are you get these CSV files, and these CSV files are, they are your actual data. This is your data, this is what you're looking for. So quite often what you would have is you would have this analysis. You would do this, and then you would do something with the results. You know, maybe you would put it into a database. Actually, CellProfiler, it does have something, it does have like an export to database utility, but maybe you want to do something a little bit different. You want a bit more, you want a little bit more manual control. Maybe you've had enough and you're just going to throw it all into a MongoDB database. You know, I don't know. But there are quite a lot of things that you could do. Maybe what you want to do is you want to actually take each one of these and you want to apply some kind of QC metric to it. And then based on the QC, maybe you want to flag somebody, you know, say, oh, hey, this did not work as expected. Or you could do things like you could just generate plots on the fly. You know, you could take each one of these and then I have no idea what kind of plots you would use for this. But let's say that you knew what you were doing, because I am not a biologist. But let's say that you knew what you were doing. You wanted to generate some plots. You could do that. You could say right here, okay, where is this? Once this analysis stream is done, complete this other task, and this other task is something like put my data into a database, generate plots, do some kind of QC metrics, alert people if the QC is not as I expected. And this is why it's really nice to have, you know, to have all of these different things. Or this is why it's really nice to use a framework that just makes this very easy. There's also, of course now I don't remember what it's called. Oh, my computer is like really freaking out here. Okay. There is also, I don't know what it's not liking. But anyways, there is also when you have each of the operators, there's like a success and failure callback. So if something is successful, you could alert somebody, you could update your project management system, you could have, if you have kind of like a lab wiki or anything like that, you could update that programmatically. There's a lot of cool things that you could do. I'm going to go through actually, and I'm going to kill these two because I kind of feel like this is maybe a bit much for my computer. And this is why it's important to do profiling and to know exactly how much your computer or your server or your cluster or your whatever, what it can actually take. Because I don't know. I'm not so concerned by like killing servers or crashing servers. They're pretty easily restarted. But my laptop is actually, it's kind of important to me. It's important to me personally. The servers, I'm not buying those. Those are somebody else's problem. Okay, so let's go look at the ones that was already finished. Because then you can see all the logs. Maybe it's a little bit more informative for you. Maybe it is, maybe it's not. Oops. Oh, okay, this is fine. So you can see this is the analysis. It runs once because it ran properly the first time. And then there you go. So you see the whole thing, it ran. And then it has this final export to spreadsheet. This is like what I always look for with these things is, with CellProfiler anyways, is that I see this last line that says export to spreadsheet. If you don't see that, there is a very high probability that something somewhere went very, very, very strange. So I think that's that. Oh, one other thing that I think is a little bit nice about Airflow is that you have different connections, and the connections connect to different data sources. So, you know, you see all of these, right? So what you could do is in the Airflow interface is you could actually like on the command line on the interface, so on and so forth, you could program in all of your different connections, and then if you have users who are using Airflow, then they could just reference that connection. They don't need to specifically know the username and password. If you're really concerned about security, as I know some people who are not me are, then that might be a nice consideration for you. I don't know. This is it, you guys. My computer is really dying here. But anyways, that is the end of the video. I hope that this was helpful for you and that you can kind of see how you can design some really big, complex, pretty cool workflows so that then you can get your analyses done, get yourself some nice plots, generate all of your data, have it all done in one fell swoop. And that is it. Thank you. Have a nice day. Bye-bye.